Hello, pretty people. I am Binz, reporting for duty in a new video of the Shapez BEASTMAM series. Welcome. Before we dive in, I've got a little public service announcement to make. Between last video and this one, I've had a few issues with my save games, and that explains, among others, why the level 3000 shape you see on the hub is a different one than it has been in previous videos. While I did have this factory saved, I didn't have it backed up in its latest state, so I've had to revert to an earlier save game, which luckily was still largely the same, but not entirely. So in my attempts to redo those bits and pieces that were lost, it's highly unlikely I recreated every last belt and wire exactly the same way it was before. But all in all, those differences will be minor and insignificant, so no reason to panic. However, while dabbling with the factory again, I did end up at a few places on the wiring layer where I noticed redundancies. More specifically, at one point, it had been my idea to create one hybrid type of input module that would be able to produce both flat and floating pieces. And there was still a bunch of obsolete wiring going on that reflected that approach and that I hadn't cleaned up. Long story short, I've decided to upgrade the BEASTMAM from version 1 to version 2. So that's what we're going to work with in this video and in upcoming videos as well. All right, with that said, we can move on to today's video. Now, last time we spoke about the way in which we analyzed the flat pieces by their smelt composition to determine a rotation for the input signal so that it would fit a fixed cutter setup. And I feel like that was quite a hefty subject. In the second section of our topic, wiring, I want to talk about various other ways in which we're going to play around with the input signal in order to make this factory work the way it does. Therefore, our second section will be called Input Manipulation. But this section will be handled in multiple videos as well. So not only do we start a new section, section 2, we will also dive into subsections. So on today's menu, subsection A, in which I would like to talk to you about something I call a Penta piece. Now, don't worry, a Penta piece is yet another term I've made up, so you're not supposed to know what it means, nor do I expect you to adopt it in your vocabulary. However, it is a very powerful technique that I would like to share with you. The Penta piece, or whichever other name you want to give it, is a type of code shape that's actually become my go-to method for handling MAM input lines. If you're a player yourself invested in Make Anything machines, then this video might prove very useful and inspirational for you. You don't even need to be building TMAMs, it works for normal MAMs as well. But what is it? Well, a Penta piece is a shape piece that consists of 5 identical quadrants distributed from the bottom upwards. In other words, it's a 2-layer shape in which one and the same quadrant appears 5 times. 4 of them are on the first layer and the 5th quadrant is on the second layer. The quadrants themselves may be of any base form, circles, squares, stars, windmills, doesn't matter. And they may also be of any color, including also gray or uncolored. That doesn't matter either. All that matters is that the first layer has this quadrant 4 times and the second layer has it once. You can use this Penta piece technique in contexts where you are in the process of isolating the quadrants of any layer of your target shape. The idea is that you transform each of those quadrants into a Penta piece, paying attention to the fact that the quadrant on the second layer of the piece is in the same corner as the one in your source. So in this example, if you look on screen, you can see that just like the source shape, the red Penta piece has a quadrant in the top right of the second layer, the green one has it in the bottom right, and so on. Okay? Now, what purpose does this serve? Well, in your MAMs, you will pretty much always work with an input system that has some form of filter setup, right? A system that filters out the specific shapes and paints that you will need for production and that blocks or trashes the things you don't need. And now the idea behind the Penta piece is that you can minimize the wiring footprint of those input lines if you provide a potent, solitary source signal with which you can operate all of those input filters at once. That's the idea. So let's look at an example. First, we are going to create a Penta piece, and that is very easy. So we start from a single quadrant, and for our example, let's say it is a cyan star in the bottom left corner or something like that, right? The creation of a Penta piece is very simple. You're going to make a fork in the road. You're going to create a rotation, a 90-degree rotation, and then you're going to just stack that line back to the initial line. And you're simply going to repeat this 4 times. So 1, 2, 3, well, repeat it 3 times, but 4 times in total, right? And that's how you create this type of piece. It is super easy. And now I want to show you why it is such a powerful tool. So we're going to continue this wire to the right. And first, in your machines, you are highly likely to have some kind of input system for selecting shapes, right? Disregarding the Shapes Industries mod, you are going to have 4 types of basic shape forms: the circles, the rectangles, the stars, and the windmills. And you're probably going to have some form of filter system for it. So now, from this Penta piece shape, I can retrieve the star very simply. I can just hook up an analyzer and I connect the shape output to those filters. So you don't need complicated extraction modules to retrieve the signal that you need from this Penta piece incoming source signal, right? All you need is one analyzer unit, and the left-hand side, in this case, you connect that to your shape filter. Now, let's continue. In your setup, in your input setup, you are also going to have some form of color input, right? And it works exactly the same way. From this Penta piece, you can connect an analyzer unit, but you pick the other side, and that will automatically choose the correct color for you. Now, usually, generally, those shapes and those paints, they will run into some kind of painter, right? That is pretty customary. So for this painter, you are probably going to want some kind of bypass for the cases where you have gray paint. So for example, what I could do is I'm going to set up a comparing unit right here. I'm going to let that match with uncolored or gray. We still need a NOT gate in this case. And again, just the same as I did here, I can use one single analyzer unit because we are going to reuse the color output of it. And now the system recognizes that we don't have an uncolored shape, and therefore the shapes are output in their, in their painted form. Now, if you are a bit advanced with ratios as well, you will probably know that one of the most efficient forms of doing this is outputting a quarter belt of a full shape, which you are then going to quad cut in order to obtain the quadrants, right? So that is what I'm going to do here. But in this setup, if you don't know in advance which rotation you're going to want, you are also going to need some kind of rotation module that determines what that is. Okay, so what I am going to do here is I'm going to take these lines and I'm going to set up a rotation module. So for example, oh yeah, I had some residue left here. For example, I'm simply going to put a filter here, here, once again here. And every time I'm going to tell the machine, you know, if the shape that passes through is not the one we want, is not the actual quadrant we want, then you send it into the secondary output. You're going to rotate it 90 degrees, and then you're going to check again. Rotate 90 degrees, check again, rotate 90 degrees. And at the latest then, we have gone through all of the 4 potential rotations. And so at the latest then, we need to have a match, right? So now back to our input line. We are going to take this piece and we are going to want to connect that to all of these filters. And all we need to do in order to obtain the thing we need is this time not an analyzer, but an unstacker. We take the top layer of this Penta piece and then we simply connect that to these filters. For good measure, I'm going to add a 0 module onto here, a 0 annex. And what do we see? We get a full belt of the quadrant that we need. And that then feeds into probably a stacker unit of your machine. Okay, so that's how that works. Let's look at another example. Let's say we take a Shapez Industries specific one for this time, and let's make it white. There we go. Yeah, the reverse windmill, why not? And I should have thought ahead. I didn't have that in my setup. So not a Shapez Industries specific one. Let's take the regular windmill then, all right? So regular windmill, and just the way we saw it before, but now with the windmill is output, the white color is output. Both of them meet in the painting module. They go into the quad cutter, and we rotate until we keep exclusively the correct rotation, which in this case is the top left quadrant. All right. Now, within the progression of this BEASTMAM video series, why did I decide to talk about these Penta pieces now? Well, because we've arrived at a point in the production process where I have used them. This is the input line of a flat piece in the BEASTMAM. And last time we spoke about how the first thing I do with it is redirect it into a module that will rotate it based on how it will be smelted and cut. And then the rotated signal comes back, it's been stripped of its color, I cut the shape into 4 quadrants, and, well, I turn them into Penta pieces. Now, while all in all, this is actually just a minor and rather insignificant step in the entire process, I did feel like elaborating on it in a single separate video. I figured this technique might be useful to you as well. If you're a player, if you have been building MAMs or experimenting with them at least, then you may consider using this technique. It allows you to hook up your factory's input lines with minimal wiring, which means that the space you save could be used to shrink down your factories, thus optimizing them and making them more efficient. All right. So I hope you enjoyed this little tangent, let's say a maybe tutorial-like video within the BEASTMAM series, but don't despair. Next time we will go back to topics that explain specifically how this particular factory works. And as always, I'd obviously love for you to join me as well. Now, I am morally obligated to remind you to click the subscribe button and the notification bell if you want to stay in the loop. And obviously, I'm always happy with a thumbs up or a comment on this video. So, thank you for watching, and I will see you next time. Have a great day and take care. Bye.